When integrating generative AI into an enterprise product, solutions architects face a fundamental architectural crossroads. Should you host your own LLMs on raw GPU servers, or should you rely on managed API providers like OpenAI or Anthropic? At first glance, self-hosting seems like the correct choice for maximum control and data security. You run open source models inside your own virtual private cloud. But as you scale to millions of users, the operational reality of managing GPU clusters catches up with you. SAs must understand the hidden costs of GPU compute before choosing an architecture. In software architecture, every decision has a tax. For self-hosted GPUs, that tax is paid in three ways. First is scaling latency. Unlike microservices, which spin up in seconds, giant LLM containers can take minutes to load weights into GPU memory, making them useless for sudden traffic spikes. Second is hardware scarcity. Securing dedicated A100 or H100 GPU reservation agreements with cloud providers is a bottleneck that can stall your product rollout. Third, and most expensive, is over-provisioning. To meet peak traffic SLAs, you must keep massive GPU clusters warm, paying for extremely expensive compute even when user traffic is low. To eliminate these three taxes without locking themselves into a single cloud provider, architects are adopting the multi-cloud LLM gateway pattern. Instead of hard-coding API keys and model clients into application code, you route all LLM requests through a central decoupled gateway tier. This gateway manages weight limiting, tracks token consumption per tenant, and masks PII. Most importantly, it performs dynamic traffic shaping. By measuring real-time latency and error rates across providers, the gateway can route a request to AWS Bedrock, GCP Vertex, or Azure OpenAI based on whoever is fastest and cheapest at that exact millisecond. Pushing enterprise data across multiple clouds introduces massive compliance challenges. To satisfy regulations like GDPR, HIPAA, or FedRAMP, your routing gateway must enforce strict data boundaries. This means utilizing zero data retention agreements with managed API providers, ensuring they never train models on your prompts. You must also implement tenant-aware routing, restricting European customer data to European cloud regions. Finally, utilizing PII masking middleware inside the gateway before token serialization ensures sensitive data never leaves your secure compliance boundary. Let's ground this in a major real-world case study. On May 2026, the Slack engineering team published their journey to multi-cloud. When they first built Slack AI, their architecture was single provider and self-hosted. They ran open source models using AWS SageMaker. To protect customer data, they built a sophisticated escrow busy system, keeping data isolated within secure boundaries. While this design satisfied security requirements, it hit the three serving taxes hard. Slack faced immense operational overhead managing GPU nodes, struggled to secure enough high-performance hardware, and spent millions on over-provisioned idle GPUs to meet demand. To scale Slack AI to millions of users, they evolved their architecture. They migrated away from raw SageMaker GPU management, adopting Amazon Bedrock and a federated multi-cloud routing layer. Bedrock provided serverless scaling for frontier models, shifting the burden of GPU availability to AWS. By combining Bedrock with a multi-cloud routing strategy, Slack gained the flexibility to route workloads dynamically. If one region faced GPU congestion, they failed over to another, maintaining strict SLAs. This transition eliminated their feature lag, allowing them to roll out new AI tools instantly while drastically reducing their infrastructure bills. Let's summarize the architecture takeaways. First, decouple your application logic from LLM APIs by building a routing gateway from day one. Second, avoid self-hosting raw GPUs. The taxes of cold starts, hardware scarcity, and over-provisioning costs are rarely worth it. Third, enforce strict compliance boundaries using zero data retention, APIs, and region-restricted gateways. And finally, Slack's architecture proves that multi-cloud federation is the mature path for scaling generative AI across the enterprise. Thanks for watching.